This is an introduction to how to make a basic line graph using LoggerPro. And for our example today, we're going to use the data from an experiment to determine the density of steel bearings. So in the laboratory, we've already collected the data for the mass and the volume of the bearings, and now we want to plot a graph to determine the density of the steel ball bearings. So the first thing I'm going to do here is double click on the X to bring up this window of manual column options, and this is where I'm going to record my volume data. For the short name, we'll just give it a V, and for the units, cubic centimeters. And here's a nifty little option that if you click here and go to superscript and then 3, you can see now that my units are in cubic centimeters. And when I click done, you'll see that down here on the axes I've got volume in cubic centimeters. I'll do the same thing for the y-axis, where we'll record our mass data. So this column will be mass, and we'll just call that M, and our unit in grams. And you can see that now on the y-axis we also have that labeled with the units. And while I'm constructing my graph here, I might as well go ahead and give it an appropriate title. So if I just double click here on the top, I get this window that says Graph Options, and I'll give it a title, Density of Steel Bearings, and click OK. And now our graph is set up. Now we just need to enter our data. So for the volume, 0.6, mass 5.54, 1.5, and 16.41, 4.0, and 28.09, 8.0, 65.07, and then lastly 12.0 and 95.65. And you can see that as I typed in the data, it's already plotted this for me. If I want to change how the data points look, all we have to do is double click on them, and under options we can then choose what we want them to look like. Do I want it to be an empty circle or a filled circle? I can change the color. I quite like red, so I'll just go ahead and leave it as red and click done, and then there are all of my data points. Now we want to make sure that we scale our graph appropriately so that we can see all of the data points and it fits our page very nicely. So an easy way to do that is just to come down to the axes, and as you move your cursor across it, you'll get this little symbol. If you click and drag that, you see that you can automatically rescale this so that you can see all of the data points. You can do the same thing on the x-axis to scale it appropriately also. I just want to make sure that I'm able to see all of the data points clearly on my graph. The last thing that we need to do on a basic graph is to add the line of best fit. And there are a couple of different ways to do this. Under the Analyze menu, you'll see that there is a linear fit option, and if you just click on that, it automatically draws a line of best fit, and you can see that it gives you the slope, the y-intercept, your correlation, and your root mean squared values. However, we don't want to do this. Many times the IB will actually penalize you for doing an automatic fit like that, so we'll just close that and go back to Analyze and choose Model, where now I'm going to manipulate the line to give what I think is the best fit. And looking at my data, it looks pretty clear that it's some sort of a linear relationship. So I'll click that and OK. And you can see that the line here doesn't fit my data at all. What you need to do now is double-click inside the box and choose Enable Line Drag and click OK. Now what I can do is simply by clicking and holding these diamonds that are there, I can move this data, move the line, to be wherever I want it to be. Now, since I know it's supposed to be a linear and direct relationship, I'm going to make it go through the origin. And then my line of best fit, I want it to hit as many points as I can, but also I want to miss as many points on the top as I do the bottom. So I want to drag this down just a little bit. And you can see that here I have a pretty good line of best fit, that I'm hitting definitely 3 of my data points, and I've missed 1 data point above and 1 data point below. And if you don't like where the box is, it's very easy. All you have to do is click that to move it around. And you can see that also it's giving me a slope of 8.037 to within 1 significant digit, or 2 significant digits in this case, my density of the steel balls would be 8.0.